right, so here's a practice test. I told you I'd try this, see if it works for you any better. So problem number 1, think of each segment in the figure as part of the line. All angles are right angles. So on A, which line is parallel to HG? So if we're going to talk about HG, we're talking about this line right here. Remember, they said we can make it a line. So if we look at that one, which ones are parallel to that? Well, if we look at it, we could say this line here is parallel, right? So one of our answers would be EF. And one of the things that I've noticed, ladies and gentlemen, is a lot of you are, when you're putting it in, you're not using the capital letters. Remember to use the capital letters, all right? So we could also look at this one right here, okay? That is also parallel to it. It's more on the top one. So we could say, or line AB. Remember, you only need to give me one of them. Then technically, if we thought about it, we could see also that this one here, all right, and this one here, DC, would actually be parallel to it also. It's just on the back of the box instead of the front. I would tell you the first two are probably the easiest ones to use, so use one of those two, all right? And again, remember to capitalize them. That's what I've noticed. So which line is perpendicular to BG? So here's our line BG. Remember, perpendicular means that it's going to meet it at a right angle. And it's telling me that all of our angles are right angles. So I could see one that would be right here. So we could say line HG. This one here would also be perpendicular to it, all right? So we could say, or AB. Or we could even say this one here would be perpendicular to it. It doesn't look like it, but remember it does have that straight angle there. And again, the one behind it over there would also be one, or CB. Again, it's only asking you for one of them, so remember that. All right, so which line is skew to CF? So here's our line, CF. Now remember, skew means that it's non-coplanar, which means it can't be on the same plane, and it's non-parallel. So if we look at here, ones that would be here, because they can't intersect either, you can see we have HE there, or AD, because again, CF would be on this plane right here, so we know that it's not going to, so they can be skew. So we're going to say line AD, or line HE. Okay. And then finally, which plane is parallel to plane AHE? Remember, you have to name planes in 3 letters. So AHE, that would be this one right here. All right, and I need a plane that is parallel to it. Well, the only one is this one right here. So that would be parallel to it. So we would say plane. And again, remember, you just have to use 3 of the points. But again, capital letters, ladies and gentlemen. So I went ahead and I said B, G, F. Excuse me. All right, problem 2. It says classify each angle pair as corresponding alternate interior, alternate exterior, or consecutive interior angles. So remember, corresponding gives you an F. Alternate interior and alternate exterior give you a Z pattern. And consecutive interior angles give you a C pattern. So let's look at 8 and 10. So these are the ones that we're going to be probably dragging and dropping them there. So 8 and 10. So here's 8. And here's 10. So this would make this look like a Z shape. And it's on the inside of the two other lines. Since it's on the inside of those, that would make them alternate interior angles. So we'd probably drag and drop 8 and 10 here. Okay. Let's see, 1 and 3. So here's 1, and here's 3. And it looks like to me, we can make an F pattern there because they're on the bottom of the F here. Remember, if I went the other way, they'd be on the top. And remember, F's are corresponding. So it would be angle 1 and angle 3 here. I'm just crossing them out so I don't redo them. Let's see, angle 4 and 14. So here's angle 4. Here's angle 14. To me, that looks like we have a Z pattern there. And they're on the outside, so they are alternate exterior angles. Angle 6 and angle 14. So angle 6 is here. Angle 14 is here. And let's see here. Looks like we have a backwards F here. Again, just look for the shapes here, ladies and gentlemen. So that would be, again, F is corresponding. So we would say angle 6 and angle 14. So 3 and 7. So here's 3. Here's 7. And if we look at this, looks like we have a Z there also, because they're on alternate sides. So, and it's on the interior of these two transversals. So we would say they're alternate interior angles. So I guess that means by elimination, the last ones have to be consecutive interior. But let's just make sure. So here's our 2. Here's our 3. Remember, consecutive would make a C pattern, which they do. So angle 2 and angle 3 go there. Okay. Identify the angles that each have a measure of 92 degrees. All right. So in that one there, okay. Again, start looking at C, Z, and F and alternate interior angles, for example. So we know that 92 is. If you look here, we have a Z pattern here. So we know that 7 has to be. Okay. And then also remember, we can also look for vertical angles. So we just said that 7 was 92. Remember, so these two here are vertical angles. So that would make angle 6. And angle 4 and 92 are vertical angles. So those are the three that would equal 92 degrees. Number 4, find the measure of angle 1 and 2. So remember, I just said, what was it I just said? Vertical angles? Well, looks like 110 and angle 1 are vertical angles. So we can say that the measure of angle 1 is 110. And again, they're going to have the degrees symbol there for you. So if we look, then we know that angle 1 and angle 2 are different because they make a C. And remember, consecutive interior angles are supplementary. So since they're supplementary, we can say that the measure of angle 1 plus the measure of angle 2 is equal to 180. We can say that 110 plus the measure of angle 2 is equal to 180. So to get angle 2 by itself, we are going to subtract 110 from 180, and that will tell us that the measure of angle 2 is equal to 70 degrees. Number 5, we can state that, again, you have to kind of think of what you know here. So if I see this here as an F angle, if that's 75 degrees, I know that that one also has to be equal to 75 degrees. Now remember, the word linear pair, we know that these two angles right here are a linear pair. They're a straight angle, so that means that their sum equals 180 degrees. So we can say that 6x minus 3 plus 75 is equal to 180 degrees. If we want to simplify the one side first, we can say that 6x plus 72 is equal to 180 degrees. If I subtract 72 on both sides, I'll get that 6x is equal to 108. And then I get that x is equal to 18. Remember, if you have time, you can always plug it in. So remember, it's 18. Okay, on number 6, it says find the value of x that makes m parallel to m. So remember, now we're going to kind of look here. There's some myriad ways that we could look at this, but I see this is what I saw. I saw that that is 6x plus 2 degrees. That would make that one also be 6x plus 2 degrees because, again, they are vertical angles. And if I see that, then I see my C pattern there again. So I know that I have consecutive interior angles. Sorry, another book always called them co-interior. So we have consecutive interior angles, and we know that consecutive interior angles are equal to 180 degrees. So I can say that 15x plus 10 plus 6x plus 2 is equal to 180. All right, combine the like terms. I can say that 21x plus 12 is equal to 180. I can then state that 21x is equal to 168. And if I divide by 21, the value of x has to be equal to 8. So the value of x is equal to 8. Number 7, determine whether there is enough information to prove that A is parallel to B. If so, state which theorem you would use. So I need to show that these two lines are parallel, right? So to show those two lines are parallel, it looks like I have, well, what do I have here? Well, looks like we have an F angle there, people. All right. So that's part of the F, that's part of the F. So we would be able to say that this here and this here angle are the same measure. So it would be, yes, we could prove that they are by the converse angles converse. Okay, in the diagram below, A is parallel to B and B is parallel to C. So this is that transitive property. So remember, if 80 is here, we also know that this angle is also 80 degrees, right? Because they're corresponding angles. We also know then that this one here is also 80 degrees because they are corresponding angles. Now, remember, this thin here makes this a linear pair or a straight angle. So we would know that the measure of angle 1 plus 80 degrees is equal to 180. Subtract 80, we know that the measure of angle 1 is equal to 100. So we would have 100 degrees there. Number 9, tell whether the lines through the given points are parallel, perpendicular, or neither. So remember, if we're going to find this to see if they're parallel or perpendicular, we have to look at the slopes. If the slopes are the same, we know that they'll be parallel. If the slopes are opposite reciprocals or negative reciprocals, then they would be perpendicular. If we don't have anything else, we would say they are neither. So again, let's see, line 1, let's call this x1, y1, x2, y2. Remember that the slope is equal to, I'll write it down for you on the first one, y2 minus y1 over x2 minus x1. So on that one there, I'll get 2 minus 5 over 4 minus 6, which will give us negative 3 on the top, negative 2 on the bottom. Negative divided by negative is a positive. So the slope of the first line is 3/2. For the second one, well, I'll do the same thing, x1, y1, x2, y2. So the slope for the second one will be 8 minus a negative 1 over negative 2 minus a negative 8. Remember, two negatives not separated by a number become a positive. So we'll get 8 plus 1, which is 9. On the bottom, we'll have negative 2 plus 8, which is 6. Remember, that can be reduced, and we can reduce that to 3/2. So looks like both slopes are the same, so that would make them parallel. Number 10, write an equation of a line passing through the point 10 and 3 that is parallel to the line 5x plus 2y is equal to 12. So remember, on these ones here, we have to get y by itself first. And remember, parallel means that we have to have the same slope. So first thing I'm going to do is I'm going to take my 5x plus 2y is equal to 12, and I'm going to subtract 5x. So I'll get 2y is equal to negative 5x plus 12. Now to get y by itself, I'm going to take and divide everything by 2. So negative 5 divided by 2, all right? Don't simplify the fraction, just leave it as it is, unless it's a whole number. So I can leave that as negative 5/2 x, and then 12 divided by 2, well, that would be a plus 6, all right? So if they're going to have the same slope, we know that our new equation has to have a slope of negative 5/2, all right? So now we're going to say our new equation, we have y is equal to negative 5/2 x plus b. So now we're going to take this point, remember this is our x value, this is our y value, and we're going to substitute those in to the problem. So I'll get 3 is equal to negative 5/2 times a negative 10 plus b. I'll get 3 on this one here, again, 10, 2 goes into 10, 5 times, so now I have negative 5 times negative 5, so I'll have 25 plus b, because a negative times a negative is a positive. If I solve that for b, by subtracting 25, 3 minus 25 is negative 22. So on this problem here, you're going to put in negative 5/2 as your fraction, and then it says plus, well, you just have a negative 22 there, so you would put a negative 22. Remember, if you were going to write it, plus a negative just becomes a minus. So your answer would have been, if you were writing it down, negative 5/2 x minus 22. But since they have it already written for you, just use the sign. Okay. Number 11. Write an equation of the line passing through the point 5 and 1 that is perpendicular. Okay. When it's perpendicular, I just told you we call them opposite reciprocals or negative reciprocals. You're going to take whatever the number is, you're going to flip it, and then you're going to change the sign. All right? After we solve it. So we get 3y by itself. So we're going to subtract that 5x over to the other side. 15 was positive on that side, so it stays that way. Now we're going to divide by 3. So y is equal to negative 5/3 x plus 15 divided by 3 is 5. Okay? So now we want one that is perpendicular. So our slope, and I just always write slope perpendicular. That's just the way I've gotten used to doing it, is I'm going to flip it. So it was 5/3, and I'm going to make it 3/5. And then I'm going to take the opposite side. Well, it had a negative, so it's going to stay a positive. So now on this one here, I can write y is equal to 3/5 x plus b. So I'm going to solve for that. Again, here's my x value. Here's my y value. So I'll say 1 is equal to 3/5 times 5 plus b. 5 divided by 5 is 1. So I'll get 1 is equal to 3 plus b. I'll subtract 3. So 1 minus 3 will give me negative 2. So on this one right here, you will write 3/5 x plus a negative 2. Okay. And then finally, our last problem. So we've had some pretty nice ones here. Okay. Last one's a thinker, but you can still do it, ladies and gentlemen. It says, find the values of m that make m parallel to n. Again, when we're talking about these, since they want us to show that they are parallel, again, we look for z angles, c angles, or f angles. On this test here, for some reason, you got a lot of f angles. Those aren't the only ones, though. Don't forget that. So if that is the case, then we know for those to be parallel that 2x squared has to equal 98. So off to the side here, we're going to say that 2x squared is equal to 98. Okay, when I divide by 2, I'll get that x squared is equal to 49. Now remember, to undo a square, you square root it. Now when we square root, we'll put a plus or minus in front. So I'll have this plus or minus the square root of 49. And if we plug that in, we'll see that x is equal to 7 and x is equal to negative 7. So I'm pretty sure it doesn't matter which one you put in first, but I would have put the negative one in first. So that's the practice test, ladies and gentlemen. Pretty simple, pretty straightforward. There's definitely not a hard one like I thought there would be. So remember, when you're practicing, your test is going to be very similar. The numbers are going to change. So just practice this, look at it, and even when you're taking the test tomorrow, do one of them, stop it, see it, and keep going. So good luck tomorrow, and study and get homework in.